Okay, welcome back. This is Mr. Hassan's Maths channel, and this is question number 1 from the June-October 2020 International A-Level Statistics S1 paper. This is actually a paper that was cancelled because of the coronavirus in June, and it was held in October instead. So there was no paper actually in June, it's actually in October that it was held. Now this question here is about discrete random variables. And it says the discrete random variable x takes the values -1, 2, 3, 4, and 7 only, given that the probability of the discrete random variable being any of those particular values is given by 8 minus x over k for x values of -1, 2, 3, 4, and 7. So these are the values of the discrete random variable that can possibly occur. Find the value of ex, the expected value of x. So what I'm going to do is I'm going to take this probability distribution function, I'm going to make it into a table. Okay, so I'm going to have a table, have x, and I'll have the probability of the particular random variable becoming x. All right, so I'm going to have here when x is equal to, it can either be -1, or it can be 2, or it can be 3, or it can be 4, or it can be 7. Those are the different values for the discrete random variable that it can possibly take. And in this row underneath it, I'm going to write down the probabilities of each of those occurring. Okay, so, oops, it's a bit too thick, sorry. So underneath it, I'm going to write down the probabilities of each of those occurring. Okay, so I can calculate each of them quite easily because we have this formula here. So we can say, for example, when x equals 1, the probability that x equals 1 is going to be, -1, not 1, -1, because that's the first value there. You'll have 8 minus -1 over k, which gives you 9 over k. So I know that this is 9 over k. And then when x equals 2, the probability that x equals 2 is going to be 8 minus 2 over k, which is 6 over k. And similarly, when x equals 3, I'll have the probability that x equals 3 is going to be 8 minus 3 over k, which is 5 over k. So 8 minus 3 over k, which is 5 over k. And the same thing with 4 and 7. When x equals 4, the probability that x equals 4, the random variable equals 4, is 8 minus 4 over k, which is 4 over k. And when x equals 7, which is the last value, the probability that x equals 7 is going to be 8 minus 7 over k, which is 1 over k. So now we have all these probabilities in terms of k. So we have 9 over k and 6 over k and 5 over k and 4 over k and 1 over k. Now what I know is that the sum of all the probability distributions is equal to 1. Okay, they're all equal to 1. Okay, so if I add 9 over k, so what that means is 9 over k plus 6 over k plus 5 over k plus 4 over k plus 1 over k is equal to 1. If I multiply everything by k, I'll have k equals, and then I have to just multiplying by k will cause all the k's to disappear. So I'll have 9 plus 6, which is 15, plus 5, which is 20, plus another 5, which is 25. So k equals 25. Okay, now we know k equals 25. We know the values of each of these. This is 9 over 25. So I can rewrite this now as 9 over 25 and 6 over 25 and 5 over 25 and 4 over 25 and 1 over 25. So they're all now over 25. And I can find the expected value. If you remember, the expected value, to kind of treat like this like a frequency table. So you multiply the x by the probability of it occurring. So and then you find the sum of each of these. So it's -1 times. So we can say the expected value therefore of x is -1 times, and that was 9 over 25. Plus, and we have 2 times, the second was 6 over 25. Plus, and you have 3 times 5 over 25. And then you have, was the next one 4? Yeah, 4 and then 7. Then you have 4 times, and then the next one was 4 over 25. And the last one was 7 times 1 over 25. Okay, so that is going to be our expected value of x. Now, they all have the same denominator of 25. It's going to be like -9 plus 12 plus 15, move that along a bit, plus 15, plus 16, and plus 7 all over 25, and that will be my answer. So you have 12 minus 9, which is 3, 18, 18 plus 7 is 25, 25 plus 16 is 41, so you have 41 over 25. So therefore we can say the expected value of x is equal to 41 over 25. And there's the answer to this question. I don't know how this question slipped through the net. It was just one question actually missing from this paper. I'm answering this like a couple of years after the event, but all the other questions are on the playlist and uploaded. For some reason, this question, I think nobody even asked about it because it's quite an easy question. So nobody really needed me to answer it, but some student just asked me to answer it on the channel. And so I found that it was actually missing. So I've now rectified that. So that's the answer. That's the expected value of x. And that is the end of question number 1. Nice, easy break-in question for the paper. Not too difficult. You have to just understand what these, discrete random variable topics is about. Thank you for watching. Other questions from this particular paper you'll find in the playlist that will appear in this region over here. Other questions from discrete random variables in the playlist over here. You can subscribe to our channel by clicking on the banner that will show in this area. And at the top here, you will find a link to a video which will teach you how to use my channel in order to find things that you might find useful. Thank you for watching and see you soon.